This is a homework problem out of Chapter 9, Section 1 on correlation. So the problem says the accompanying table shows the maximum weights in kilograms for which one repetition of a half squat can be performed and the time in seconds to run a 10-meter sprint for the 12 international soccer players. So let's see what's going on here. Let's look at the data table. So you have to click here. Here's the actual data. We're trying to match this data with the scatter plot. So what I'm going to do is, just to make it a little bit easier, is to put in StatCrunch. And let StatCrunch do a scatter plot for me and just compare. So these are my X's and Y values, and StatCrunch will put that on a graph for us. Oopsie, stat, regression, simple linear. X variable is the maximum weight, that's our independent variable. The Y is the time, which is our dependent variable. And compute. Here's right here is the scatter plot. So that looks to be very strong negative correlation, just looking at the scatter plot. So let's see which one it looks like. So it's definitely not this one, and it's definitely not this one, because those are positive going up. It's one of these two. So it's just a matter of matching them up, and I'm seeing this little pattern of dots here for the weight. Looks like right around 150, and up here around the 2.2 for time. So I'm seeing that little cluster that matches this cluster. So I'm going to pick B. Now it's asking us to find the correlation coefficient, R, and then we're going to find our critical value to see if we have correlation. It's looking pretty good. So let's go back in StatCrunch and see what R is. R is right here, so it's negative because it's going downhill. We have negative correlation. Looks pretty strong to me, so negative negative 0.938. Oops, what in the world did I do? Let me go back. Negative 0.938 is R. And so we need to, I'm going to go ahead and get that going. It does appear that there is strong negative correlation, is what it looks to be. Just looking at it, it looks very strong. These dots are very tight. It's going downhill. R is very close to -1, so it does appear to be strong negative correlation. So we would say, I know it's not A, and I know it's not F. So, and we know that as the, let's see, let me look back at our graph here, as the weight increases, time decrease appears to be choice B. So the next part is to find the critical value, and that comes from the chart here. And we need to see how many pairs of data that we have. There's 12 pairs of data, and the significance level is 0.01. So 12 pairs of data, 0.01. The critical value is 0.708. And let's take a look. I'm going to switch over to see if we have evidence or not. So we have critical values at 0.708, which is about right here, and negative 0.708 would be down there. So if R falls in this red portion, either here or here, then we have significant evidence for linear correlation. So R, what do we get for R? It's up here, we got negative 0.938. So that's going to be about right here. This is R, negative 0.938. So we do have significant evidence of negative linear correlation. So go ahead and select that. There is sufficient evidence at the 1% level of significance to conclude that there is significant linear correlation between maximum weight for which one repetition of a half squat can be performed and time to run a 10-meter sprint.